Hey everyone, and welcome. Today we are diving deep into 5G. And I'm not just talking about speed. We're going to pull back the curtain on the actual architecture that makes it all work. It's a total redesign of how our world connects. So let's get right into it. Okay, so when most of us hear 5G, what comes to mind? Faster downloads, right? Smoother streaming. And yeah, that's definitely part of it. But that's really just scratching the surface. The real revolution, the big story, is the fundamental redesign of the entire mobile network from the ground up. So the big question is, how does it actually work? What's going on under the hood that allows it to deliver on these huge promises of incredible speed, almost zero delay, and connecting practically everything around us? All right, let's break it all down. The easiest way to wrap your head around this whole system is to think of it in two big parts. There are really just two main pillars holding everything up, the part that connects directly to you and the part that does all the thinking. So on one side, you've got the radio access network, or just RAN for short. This is the stuff you actually see, the cell towers and antennas that are wirelessly connecting to your phone. And on the other side is the 5G core. This is the intelligent brain, the central command that orchestrates the entire network. First up, let's zoom in on the RAN. This is the part of the network that's out there in the world constantly talking with all of our devices. At the very heart of the RAN is something called a GNB. Now, that's a mouthful. It stands for Next Generation Node B. But really, all you need to know is that this is the 5G base station. It's that antenna on a tower or that small box on a lamppost that your phone is talking to right this second. And this GNB is doing so much more than just blasting out a signal. No way. It's an incredibly sophisticated piece of tech. It's constantly managing network resources, scheduling data, and juggling connections for every single user in its range. It's like a high-speed air traffic controller, but for data packets. So how does it pull off this incredible feat? Well, it uses a trio of really powerful technologies. There's OFDM, which lets us pack more data into the airwaves. There's massive MIMO, which uses a whole bunch of antennas to serve many users at once. And then there's beamforming, which is super cool. It literally focuses the signal directly at your device. These three together are the secret sauce to 5G's performance. So that's how we get connected to the network. But where does the data go from there? Well, this brings us to that second pillar, the 5G core. If the RAN is the network's eyes and ears, the core is, without a doubt, its brain. And this is where 5G really breaks away from older networks. The 5G core isn't a bunch of specialized physical hardware boxes sitting in a room somewhere. It's a cloud-native, software-based system, which means it's incredibly flexible, it's scalable, and it can be updated way more easily. Inside this digital brain, you can think of it like a management team, with each piece of software having a very specific job. For example, the AMF manages your connection as you move around. The SMF is in charge of your data sessions, starting them and stopping them. And the UPF is the real workhorse that actually routes all your data. Each one has a critical role to play. One of the smartest things about the 5G core is how it separates tasks. All the thinking work, like managing connections and network rules, that happens on what we call the control plane. Meanwhile, the actual doing, the heavy lifting of your data, happens on the user plane. This division of labor makes the whole network incredibly efficient. So let's quickly trace the journey of your data. It starts at your phone, which talks to a GNB. That GNB then sends your request to the 5G core. The core then acts like a super smart traffic cop, figuring out the best route and sending your data on its way to the internet. It's a seamless three-step flow. So we've got this new, really flexible architecture. But what new tricks can it do? This brings us to one of 5G's most powerful and talked about features, network slicing. Network slicing is a complete game changer. Imagine taking one single physical highway and being able to instantly create dedicated virtual lanes for different kinds of traffic. That is exactly what network slicing does for data. You can create multiple independent virtual networks on the very same physical equipment. For example, you could create one slice, a virtual lane, just for high-speed mobile broadband, or eMBB, perfect for streaming 4K video. You could have another slice for ultra-reliable low-latency stuff, URLLC, for things like self-driving cars that need an absolutely bulletproof connection. And a third slice for massive IoT, or MMTC, to support millions of smart sensors in a city. Okay, so now that we've seen all the individual pieces, let's zoom out.
Why is this new software-defined, sliceable architecture such a huge deal?
The secret to all this flexibility is its cloud-native design. The 5G core uses technologies like virtualization, containers, and software-defined networking. This means operators can manage and scale the network just like a modern cloud application, freeing them from the old constraints of physical hardware.
Just take a look at the comparison here. The whole game changes when you move from 4G's rigid, hardware-based system to 5G's flexible, software-based one. That single shift is what makes the ultra-low latency and the incredible flexibility of network slicing even possible.
So this is so much more than a minor upgrade. This new architecture is a platform for innovation. It's the foundation that will enable the next wave of technology, from the Internet of Things to autonomous systems and way, way beyond.
So if you take away one thing, let it be this. The real power of 5G comes from the perfect partnership between that smart, efficient radio access network and the flexible, intelligent, cloud-based core. Together, they are literally building our connected future.
And that leaves us with one final and pretty exciting question. With a network this intelligent, this flexible, and this powerful now at our fingertips, what are we all going to build with it next?